Question 16 says a point object having mass m is given a velocity v0 inside a fixed smooth spherical shell. Column 1 contains different values of velocity v0 and column 2 contains information of normal reaction, net acceleration of particle at B corresponding to velocity in column 1. Match column 1 with column 2. Okay, so entry A on column 1 is v0 equal to root 2 rg. And to find, so and on the right hand side we have values of normal reaction, A total, N, and there is a statement at T that at maximum height speed of particle is non-zero. When v0 is root 2 rg, by conserving mechanical energy we know it will just reach point B. Well, let me show you how. So conserve mechanical energy, I have half m v0 square, that means 2 rg, and the gravitational potential energy is 0, is equal to mgr plus half mv square. You can see that the kinetic energy here is 0. So we get k is equal to 0, that means B will be 0 in that case. And if Vb is 0, then N also will be 0. So that means for A, S is matching for sure. So N will be 0, N is 2 mg will not be correct. A total at that position will be simply G. So Q and R do not match and speed has become 0, so T does not match. So for A, S is okay, S is matching. Let's look at B then. When I put v0 equal to root 5 rg, in fact we know that this speed is enough for the particle to complete the vertical circle, and by conserving mechanical energy we will find that the speed at point B will be, so for v0 equal to root 5 rg, speed at point B is going to be equal to root 3 rg, and that means the normal reaction at that point is equal to m Vb square by r, and that is 3 mg. Okay, and the total acceleration will be then, in this particular case it has two components. The centripetal component will be 3g, so there is 3g horizontally and there is g vertically. So the total acceleration, the magnitude of net acceleration is g root 10 by Pythagoras theorem. So that means for B, R definitely matches, P and S do not match, Q also does not match, and at the highest point we know the speed will be under root rg, so T also matches with B. Let's look at C now. So what happens in case of C? The speed at point B will become under root rg, again by simply conserving mechanical energy. And that means normal reaction at that point will be equal to mg. So, well, P will not match, but A total will match, because then at that time, that means for C, acceleration has components g in the horizontal direction and vertical direction also g. So g root 2 will be the net acceleration. So for C, Q will match, and this is the speed at which, for which the particle will lose contact somewhere here. So particle, because the speed is not enough for it to perform the vertical circular motion, for which speed minimum speed was root 5 rg at the lowest point. So particle will lose contact and at some point it will move like this. So at the highest point its speed will not be 0, its vertical component will become 0, but the horizontal component will still remain intact. So that means for C, T is also correct. Let's look at D now. So when the speed is root 4 rg, speed at this point will be root 2 rg, and that means that the normal force at that time will become m into root 2 rg square upon r, which is equal to 2 mg. So that means for D, P matches. And again the speed is not sufficient for the particle to perform the complete vertical circle. So it will lose contact at some point, and at the highest point its speed is not going to be 0. So that means T will also match. So this is our matrix match for question 16. Let's go to the next question now. Question 17 says, column 1 contains information of forces applied at two ends of a uniform string. Mass is m, length is l, cross-sectional area is A, and Young's modulus is Y. Column 2 contains elongation in string and tension at midpoint of string. Match column 1 with column 2. Okay, so there are four situations given here in column 1, and in column 2 we have parameters like delta L, T. So for A, tension at the highest point is mg sine theta and at the lowest point is 0. Tension will vary linearly, so at the midpoint, in this case, tension will simply be F2 by 2. That means for A, tension at midpoint, T will be mg sine theta by 2, and theta is 30 degree, so this is mg by 4. So that means for A, T will match. We of course need to find delta L, and in fact this will also be the average tension using which we can find the elongation. So the expression for elongation in this case will be delta L is equal to average tension, which is mg by 4, and of course the length, which is L, and then divided by YA. Now if I look at the options, well, this is matching with P. So that means for A, both P and T will match. Okay. So for A, P and T both are matching. Let's look at B now. We can see that, well, the forces are mg on both ends in opposite directions, so tension will be same throughout, and that is equal to mg. So T equal to mg is not an option on the right hand side, but the elongation we can say in for B, elongation delta L will be simply mg L by ay, and if we look at the column 2, it is matching with S, so B matches with S as far as delta L is concerned. Of course for T there is no correct match for B. Let's look at C now. For C, T will be mg by 2 because the forces are 0 and mg at the two ends. At the center it will be average of the two. So R matches for C, and the elongation delta L for C will be mg by 2, which is the average tension. In the numerator is L and here is ay, and if we look at entries on column 2, it is matching with Q. So that means for C, Q and R do match. Let's now look at D again. Well, D is similar to B, but tension at the midpoint is mg by 2. So R will match for D, and look at the elongation. Elongation will be, in fact, half the elongation that we got in B, because here the tension is mg by 2, which means it is mg L by 2ya. So that means Q will also match. So for D, Q and R both are matching. So this is our matrix match for 17. A matches with P and T, B matches with S, C matches with Q and R, and D matches with Q and R. Let's now go to the next question.